Sir Isaac Newton sit on a chair and thinks that why this apple gets down, and this is the instance where the Newton's law of gravitation starts. Now, the statement of Newton's law of gravitation is every particle of a matter attracts every other particle of a matter with a force which is directly proportional to the product of their masses and inversely proportional to the square of distance between them. The diagrammatic explanation is now here we consider 2 point masses, the mass m1 and mass m2, which are at a distance of r apart from each other. Now, according to Newton's law of gravitation, masses attracts each other means m1, this m1 will attract m2 towards, and this m2 will attract m1 towards each other with a force which is directly proportional to the product of their masses, means m1 into m2, where m1 is the mass of the first particle and m2 is the mass of second particle. Here force is directly proportional to the product of their masses and inversely proportional to the square of distance in between them. Now here in between this m1 and m2 masses there is a distance is r. Now this both masses are apart from each other at a distance of r, then this force is inversely proportional to the square of the distance which is r in between them. By combining the both expressions we get F is directly proportional to m1 dot m2, which is the product of two masses, and inversely proportional to the square of distance, that is r square. It means that as the product of masses m1 and m2 increases, the force of attraction also increases. As the product of masses m1 and m2 decreases, there is the force of attraction which also decreases. Coming to the point, finding the gravitational constant g and its unit. The mathematical expression of universal law constant is F is directly proportional to m1 dot m2 divided by r square. This is the mathematical expression. Now this we have to remove this proportionality sign. When we remove this proportionality sign, we introduce equals to, and we have to introduce a gravitational constant. This g is nothing but the gravitational constant, where F is equals to g into m1 dot m2 divided by r square. Now we introduces g, value of gravitational constant. Here F will be equals to, now this m1 dot m2 will shifted to left hand side, and this will becomes r square divided by m1 dot m2, which is equals to g, which is a gravitational constant. Now interchanging both the sides, here we get g, and here we get this side on right hand side. Now this is the value of gravitational force, that is g. This is the formula of gravitational constant g, that is equals to g equals to f r square divided by m1 dot m2. The unit of gravitational force is Newton meter square per kg square, where Newton is the unit of force, meter square is the unit of r square, that is the distance, and m1 dot m2 means kilogram, kg is the unit of this masses. Therefore, the unit of gravitational constant is Newton meter per kg square, or it can be written as Newton meter kg to the power minus 2. And the value of gravitational constant g is 6.67408 into 10 raised to the power minus of 11 Newton meter square per kg square. Subscribe Abhijit Sana Maths to get physics, mathematics, computer science, chemistry and English grammar videos and much more.